We have now started our new unit, the circle unit. And this is going to be our first lesson. It's going to be on circle definitions. And just as basics information about a circle, such as the radius, diameter, and a chord. And we'll talk about one theorem and some questions that you may possibly see on the New York State Regents exam. So let's first start off by talking about what exactly is a circle. A circle is a shaped, rounded edge, and it has a point in the middle, and this point is the same distance from the edge of the circle. Okay? So when we're talking about the circle, the first thing we talk about is the center point. Now, the center point is something we call a letter, and typically they call it O. And it's just sort of the general, because I guess because an O looks like a circle, that they talk about this circle name would be circle O. Now, the first thing we're going to talk about is a radius. And once again, these are definitions that you should already know, being in 10th grade, 11th grade, 9th grade. You should have learned this in elementary to middle school, but we're going to talk about them right now. Now, a radius is a line segment from the center point to the edge of the circle. Now, in this case, I have two radii, OA and OB. These are both radius. They go from the center to the edge, and the edge is talking about the circular part of the circle. Now, the key thing about a radius is that it's always going to be equal. So we can say that all radii are equal to each other. And now, if we're talking about that, first of all, let's just make a little note. Radii is the plural for radius. And when I'm talking about all radii are equal, if I said BO was 10, BO is a radius, so therefore since BO is 10, AO is also going to be 10. Now let's move on to our next definition. Our next definition is going to be talk about a diameter. Now a diameter is a line segment including 2 points at the edge of the circle that crosses the center point. Now in this case, BC is going to be a diameter. And now the key thing about a diameter is that the relationship between a diameter and a radius is that a radius is half the distance of the diameter, or half the length. So if you notice something here, OA is a radius, OC is also a radius, and OB. Even though B and C are connected, this OC is going to be a radius and OB. Now, if I said the radius of this circle is 8, if the radius is 8, then I can technically say OB is going to be 8 and OC is going to be 8. But as I'm looking for the diameter, BC, I can just use my brain, say 2 times 8 is 16, so the diameter of this is going to be 16. Okay, our last definition for right now, talking about line segments of the circle, is going to be a chord. Now, a chord is a line segment including 2 points at the edge of the circle. Now, in this case, I have 3 different chords. I have DE, BC, and AF. Now, BC should look awfully familiar. There should be another name for this. This is a diameter. But the key thing is that diameter is still a chord, but it's a very special type of chord. But a chord can be anywhere on the circle as long as it touches any line in the circle that is touching 2 edges. Now, a radius, for example, would not be a chord because it does not go all the way across. So if I put another line segment here, this is only a radius. It's not a circle. So we don't want to see that right now. Get rid of it. Okay? Now, the key thing is that a diameter is the largest chord of the circle. It's basically, if you notice, DE is smaller than the diameter, BC. BC is going to be the longest possible distance that you can get if you run across a circle. Okay. Now, let's talk about one theorem that has to do with these terminologies that we have. The first thing I'm going to talk about is when I have a chord, DE, and a diameter, BC. Now, if these lines are perpendicular to each other, some fun stuff happens, so please copy this down. If the diameter of a circle is perpendicular to the chord of a circle, then the chord is bisected by the diameter. So basically, if you remember the definition of bisected, it means I'm going to cut you. It means I'm going to cut it in half. So DE is going to be cut in half by BC because BC, the diameter, is perpendicular. Okay? Now, in this case, we're going to work on a couple problems with this theorem. The first one I'm going to work by myself, and then I'll let you guys do some work by yourself. The first example, let ED be 10 and diameter BC is drawn. If BC is perpendicular, symbol for perpendicular, to DE, find AE. Now, the thing is that ED is 10. I know this diameter is perpendicular, so it bisects it. So therefore, I can say that AE is going to be 5. Okay? Or 1/2 of 10. Now, if they ask me what AD was, I could also say that's 5. Now, let's take a look at one more or two more examples, but these are questions that come from the New York State Regents exam. Now, they have been putting one of these on every single exam, so I want to make sure that you guys fully understand this topic. CD is equal to 14. In the accompanying diagram of circle O, diameter AB is perpendicular to CD, and CD is equal to 14. I want to know what the length of CE is. Now, the key thing is that I know the whole thing from here to here is 14. Now, if I know this is perpendicular, we put a little symbol there, and we're looking for CE, and I'm going to put an X there to represent that's what we're looking for. I know the whole thing is 14. I know, using my theorem, that the fact that it's getting bisected, that this X is going to be half of the 14. So 1/2 of 14 is equal to 7. So therefore I can say that CE is equal to 7. Okay? And whoops, I'm not open. Alright, now let's take a look at one more problem. In the diagram below, circle O has a radius of 5 and CE is 2. Diameter AC is perpendicular to chord BD at E. Wow, a lot of words there, but they actually gave you a diagram with all this information on it already. They're telling us we're looking for BD, and since don't have any X's involved, I'm going to put a B, I'm going to put a little X here to represent this is what we're looking for. Okay? Now, the key thing is, this brings a lot of the concepts that we have already talked about together. So, if you notice one thing, all these radii, we know all radii are equal, so I could say BO is 5, OD is 5 because that's a radius, OA is 5, and also OC is also a radius. It goes from the center to the edge. I know this whole thing is 5, but however, I need to know what this part is right in the middle. So if I know the whole thing is 5, what's this part OE going to be? It'll be 5 minus 2, which is 3. Now, if I have that, now I can just look at this over here and I notice, oh look, I've got a right triangle. And I have 2 of the sides. I can figure out what ED is. Now, what theorem was that we can use? Pythagorean theorem. A squared plus B squared equals C squared. And remember, A and B are going to be the shorter parts, and C is going to be the largest part, the largest side of the triangle. So I have 3 squared. I'm now looking for this, so I'm going to put that X there. So ED, and this is 5 squared. So I get 9 plus X squared equals 25. X squared is equal to 16, and I take the square root of both sides. I can get X is equal to 4. Now that we know that information, I can put that this is 4 here. And now we can go back to our theorem that the fact that the diameter, CA, is bisecting BD. And if this part's 4, then I know this part is going to be 4. And now if I'm looking for BD, I can say that BD is equal to 4 plus 4, or 8. Okay? That's it for this lesson. If you have any questions, feel free to shoot me an email. Thank you. Bye.